Okay, so now we are moving on to solving equations that involve rational exponents. Learning goals for this lesson do include you can solve an equation for a rational exponent when the variable is in the exponent and when it's part of the base. And then you can also use your knowledge of rational exponents and apply it to a real-world scenario. All right, so kind of go back to one of the first videos in this section, and if we were able to do anything with exponents of terms, we needed the base of both of those to be identical, and that is going to play a very, very large part in understanding this lesson. Okay, same rule applies to solving equations involving rational exponents. You need their bases to be the same, exactly the same. So that's going to be something that you need to kind of keep in the back of your mind all the way through this. The other thing that's going to be very helpful is in order to get the bases the same, sometimes you're going to need to rewrite a larger number as a smaller number, as a number to a certain power. So for example, let's say we had one side of the equation had a base of 2, but the other side was 16. We can rewrite 16 as a base of 2 to a certain power. So I've given you this chart on yours, and I'm going to go through kind of some of it here. But you're going to want to memorize as many of these as possible just to make it easier on yourself. And you can see, like, 2 to the first power is just 2. 4 you get by 2 times 2, so there's 2 2's. 8 you can get by 2 times 2 times 2, so there are 3 2's. 16 is 2 times 2 times 2 times 2. So you get the idea as to how that works. But anyway, so moving right along. First example, we want to solve for x by rewriting each side of the equation to the same base. Because right now, notice we have a base of 2 and a base of 32. Okay, so I can't do anything with this exponent to solve for it until I get this to have a base of 2. So what I am going to do in order to do that is I'm going to rewrite 32. And if you go back to your table, you remember that 32 can also be written as 2 to the 5th power. Okay, now we have two bases that are the same. They both have a base of 2. And since their bases are the same, we can go ahead and we can take these parts and set them equal to one another in order to solve for x. So now I'm going to move on. I'm going to take just the powers and set them equal to one another. And then I'm going to solve like I normally would. So I would subtract 6 from both sides, which is going to give me an answer of x equals -1. And that's all I was asked to do was solve for x. So I'm done. All right, second example. Again, we have to solve for x by rewriting each side of the equation to the same base. However, x is now not in the exponent, so you might be a little confused. So what we're going to do is we're just going to kind of put it aside for right now. We're just going to not worry about that. We're going to focus on these here. Okay? So we need to figure out what 27 to the 2/3 power is, what 125 to the 1/3 power is. And the easiest way to do that, again, is to knock them down to the simplest base to a power. So in this case, 27 can be written as 3 to the 3rd power, which is what I did here. 125 can be written as, now keep in mind to write anything to a power, if you're going to try and break it down like this to figure it out, they all need to be the same number. You can't have any other number in here. So this can be written as 5 to the 3rd power, which you can see that I did right there. Okay? So the reason why I did that is because now I have something equivalent to the denominator, which is really what I was going for. I was looking at the denominator and I said, is there a way that I can raise this as a base to the 3rd power? You know, if this was to the 4th, then I'd be looking something to the 4th power. Because what I want to do is 3 times 2/3, those 3's cancel out, leaving you with just 2. These 3's cancel out, leaving you with just 1. So you have x times 3 squared equals 5. X times 9 equals 5. And again, our goal is to get x by itself, so we're going to now divide both sides by 9 so that this cancels out over here, which leaves me with an answer of x equals 5/9. Okay, and again, we're going back. We're basically doing the same thing. It's slightly harder. Our variable is back in the exponent. So we have 4 as a base. I want to get this. I want to hopefully get 64th so that I can write, rewrite it with the same base. So rewrite it with 4 to a certain power. Worst comes to worst, I could rewrite this as a 2, and I could hopefully rewrite that as a 2 as well. But let's see if we can do it to the 4th. So if we went back to our table and we looked, we would see that 64 can be rewritten as 4 to the 3rd power. Okay, so now again, same base. So now we have to set the powers equal to one another. X over 3 minus 2 equals 3. And we haven't had a whole lot of things set up like this, but you're still going to do the same thing. So first, add 2 to both sides. Don't worry about a common denominator. Okay, there's no variable with this, so we just want to go ahead and add that to both sides so that it zeroes out on this side. So I get x over 3 equals 5. And then you can see I'm multiplying both sides by 3 because that'll get rid of this. Remember, you do the opposite. X over 3 is like saying x divided by 3. So the opposite of division is multiplication. When I multiply by 3, it gets rid of it, leaving me with just the x. 5 times 3 is 15. Okay, so now we've got a word problem. So if the area A of a circle is known, then the length of its radius, r, can be computed by the following formula. So we've got r equals a over pi, and the whole thing is raised to the 1/2 power. We're told what a is, and we're told what r is, and we need to solve for x. So we're going to plug in the different pieces. So this 49 pi is going to go in for a. This is going to go in for r. Okay, so we plug those in. Notice right away that the pi's cancel out, leaving me with this, because the pi's are gone. So 49 to the 1/2 power. Remember that 49 can be rewritten, or that 49 to the 1/2 power can be rewritten as the square root of 49. Square root of 49 is, in fact, 7. So now we have 7 to the 4x power equals 7. So what we need to do is, we have similar bases, right? And we have an exponent. You might be wondering what this is. Well, if there's nothing there, it's a 1. So we set 4x equal to 1, divide both sides by 4, thus getting rid of the 4, the coefficient, which leaves me with x equals 1/4. The other thing you could do with this, instead of going the square root route, is you can say, well, 49 to the 1/2 power, that's the same as saying 49 is the same as 7 squared to the 1/2 power, which the 2 and the 1/2 would then, cancel each other out again, also leaving you with 7. So there's a couple different ways you can arrive at your answer. And then finally, the physical motion of an object is modeled by the function s equals 3.8 t to the 1/3 power, where t is the time, measured in seconds, and s is the position of this object, measured in meters. Find the time when s equals 11.5 meters and round your answer to the nearest hundredth. So we're going to take our formula, except we know that s is 11.5. So we're going to replace s with 11.5. Now notice we only have one variable in it, so we should be able to solve for that. We're going to start off by dividing both sides by 3.8, because again, the idea is to isolate the variable. Okay, get rid of the 3.8 on the right side. 11.5 divided by 3.8 is this large number, not large, but this long number that doesn't end, 3.02631, etc., equals t to the 1/3 power. Now I want to solve for t, not t to the 1/3. So how can I do that? Well, I can raise that again to whatever's in the denominator, or you can think about it as raising it to the reciprocal so that I end up with an exponent of 1. So it'll be just t to the 1st power or just t. But anything I do to one side, I have to do to the other. So since I raised this side to the 3rd power, I have to raise this side to the 3rd power, like you can see, which gives me t equals 27.716777723, etc. But it said to round to the nearest hundredth, and it's a word problem, so I need to make sure I have units, and my answer is 27.72 seconds. And that is it. If there are any questions, anything you don't understand, I suggest going through it step by step, and also writing down your questions and asking them in class. And that is all I have for you, boys and girls. So you have a lovely day. Take